Okay, sorry about this. This is the continuity of the video number 25. Suddenly, someone called me, and okay. Anyway, so let's continue with that. The function v given by ax squared plus bxy plus cy squared is of positive type, if and only if a is positive and b squared minus 4 ac, this is negative, and it is a negative type. It is of negative type, negative, if and only if a is negative and b squared minus 4ac negative. Oh, sorry about this. Okay, so we have this. Let me repeat those. The function v with ax squared plus bxy plus cy is of positive type if a is positive and b squared minus 4ac is negative, and it is a negative type if a is negative and b squared minus 4ac is negative. So if you look at those two examples, the previous example that I mentioned, the choice of v is basically of that form. So I would like to suggest for any problem, I cannot say for any problem to comes, but generally we choose a function v as ax 2m plus by 2n, and we choose the appropriate a, b, m, and n, so that by choosing those a, b, m, and n, we can see what type of v, and hence we can come up with the conclusion to our problem. I give you another example here. Let's consider this example. If you have x dot equal to minus y minus x cubed and y dot equal to x minus y cubed, and we consider the function v, let v of this form, you can use this type of function, okay, and then we make choice of a, b, and mn. So ax 2m plus by 2n, okay, and then we find the, of course in this case, from here we can find the only critical point is 0, 0, and definitely for v, a positive, b positive, we have a positive v, okay. But if we differentiate those things, again we have this is 2m ax 2m minus 1. Our f is that, so that negative y minus x cubed plus this one 2nby 2n minus 1, and our g is x minus y cubed, okay. Then if we simplify this, we have, so what we have, this is a negative 2m a x 2m minus 1 y, then negative 2m a x 2m minus 2, right? And for that we have plus 2n by 2n minus 2n 2n minus 1 x and 2n by 2n plus 2. So what can we see from here? Yeah. What can we see from here? If we choose m equal to 1 and n equal to 1, what will happen? Yeah, n equal to 1, so we have 4 here. That's x4. Then here we have y4 here. Here we have x4. And we choose a equal to 1, b equal to negative. So what happened here? A equal to 1, b is negative 2. Okay, I think we can choose I can choose a equal to 1, b equal to 1, so we have m equal to 1 and n equal to 1. So what happened there? So v0 becomes, we have all 1, so we have negative 2 xy minus 2 x cube, no, 4. Here we have plus 2 y x. Here we have minus 2 y 4. Okay, of course from there I think you can rewrite this as you can factor out x, so that we have 2x. You can factor out 2x, so we have minus y minus x cube, and for this you factor out y, we have 2y x minus we don't have x, 2y, oh yeah, so we have y cube. Alright, so that will give us that so I think basically this we can cancel out there, much easier, and then you just deal with that, so you don't need this. This is so minus 2 x squared plus x4 plus y4. Yeah, that's it. Okay, so we have from there, this is definitely positive, so if we have a negative in front, so this is negative, so therefore v0 is a negative definite. So therefore the point 0, 0 is asymptotically stable. Okay, and of course I have another example for the case of unstable. Okay, let me give you one more example for the case of unstable. Another example, x dot equal to 3x plus y squared and y dot equal to minus 2y plus x cubed. So we consider the function v xy of the form ax2m plus by2n. Okay, and if you check this, the critical point is 0, 0. That's the critical points. And then we find, of course, v00, this is 0, then other than that is gives you positive. Then v dot xy, we have here 2na x 2m minus 1, and then our f is 3x plus y squared plus 2nby 2n minus 1. Our f is negative 2y plus x cubed. Okay, so we have those. That. Okay, then if we can simplify this, so what we have, this is so you have 6ma x 2m for that, plus 2m a x 2m minus 1 y squared, and for those we have minus 4 and b y 2n plus 2n b y 2n minus 1 x cubed. Okay, all right, so now the choice of m here, if we can choose m and n in such a way that we can combine, I mean we have same power of any of this, it would be much better. Yeah, so I have y2n here, we have y squared, we have here, so I might choose mn equal to, if we choose m equal to 1, n equal to 1, so what will happen here, we have x2, just we have x here and y squared. Okay, and here we have y squared, here we have y1 x cube. I think we can factor out somehow. And if we choose m is 1, so 6 is 2, so b, here b 4. Can we choose a equal to 1? Let's see, b equal to, if we choose b minus 1, so y x cubed. Okay, b is minus 1, see what happened. So this becomes, we have 6 x squared plus 2x y squared minus plus 4 y squared minus 2 y x cubed. Okay, and then okay, so we have that quite the dominant terms. So we have 6 x squared plus 4y squared, and those 2x y squared minus 2yx x cubed. Okay, I think we can conclude now. If you look at this, if for small x and y, yeah, for small x and y, we need to consider a magnitude because we have x cubed here. Okay, and we also have y. So if for small x and y, which means we have x is small enough and y is small enough. In other words, if this is the critical point, our x and y is just very close to the critical points. Yeah, very close to the critical point. So for small x and y, so definitely this v naught here, this part is more dominant than that. Okay, because here you can see we have x, we have a power of 3, here we have a power of 4, here a power of 2. So for small x, which means x is less than 1, or maybe you can choose smaller than that, so definitely this part is more dominant. So this is positive, then therefore it is obvious for small those things, obviously that v is positive. Yeah, positive. So therefore, yeah, v is positive near 0 0, the origin, near the critical point. So therefore 0 0 is unstable. It's unstable. Okay, so with this example, so we have I have covered the liapunov direct method to investigate the behavior of the solution near the critical points. All right. So this is the end. I think this is the end for the undergraduate for MTH 4102. So next we are going to for the master course, I will extend a little bit our notes. So for the undergraduate, so this is our last lecture. So for that, I'm very sorry if any mistake you are may not happy with this kind of lecture, but we don't have much choice. This is for the moment, that's what we only have. So this is the and for the postgraduate, master and PhD, we are going for the next part, which covers Laplace transform, Mellin transform, and the other one is I forgot that one. We have three transform to cover. Yeah, so with that, I thank you. See you next time. Bye.